Hello everyone, welcome back to my Blackboard. This is Ravichandra. Welcome back to our channel Rust Planet. In today's video, we are diving into the concept called linked list. First of all, what is this linked list? A linked list is a data structure that consists of a sequence of nodes, each containing some data and a pointer to the next node. A node in a linked list is an element that contains two parts called data and a pointer. A linked list allows efficient insertion and deletion of elements at any position but does not support random access. To access an element, you must traverse the list from the head node, which is also called as the first node in the list. The last node points to null, indicating the end of the list. There are three types of linked list, such as single linked list, double linked list, and circular linked list. Single linked list. In a single linked list, each node contains a reference to the next node in the sequence. Traversing a single linked list is done in a forward direction. Next, double linked list. In a double linked list, each node contains references to both the next and previous nodes. This allows for traversal in both forward and backward directions, but it requires additional memory for the backward reference. And the next one, circular linked list. The last node points back to the head node, creating a circular structure. And coming to the operations on linked list, there are mainly two operations, insertion and deletion. Adding a new node to a linked list involves adjusting the pointers of the existing node to maintain the proper sequence. Insertion can be performed at the beginning, end, or at any position within the list. Now coming to the deletion, removing a node from a linked list requires adjusting the pointers of the neighborhood nodes to bridge the gap left by the deleted node. Deletion can be performed at the beginning, end, or any position within the list. In this video, I am going to explain the insertion and deletion in single linked list. Let us see how the insertion and deletion happens. I am going to explain how new value is inserted in the single linked list. I am going to explain how new value is inserted in the single linked list. Let us see this example once. Here, the node that is holding the value of 45 is the head node, and the node connected to the head node is the next node of the single linked list. Address of the second node 2000 is stored in the head node. Now our task is to add another node to this linked list. For this, first step that we should do is we should store the address of the head node, that is 1996, in the new node. And the second step is to shift the pointer which is pointing to the head node to the new head node. That's it. Insertion of the linked list is completed, and the new node will behave as the head node for the entire list. Okay, now let us see how deletion process takes place. This is quite opposite process to the insertion process. In insertion, we shift the pointer from the head node to the new node. In deletion, we assign head to the next of the next node and middle node will be released from the link. Hence, second node is deleted from this list. Now let us dive into the coding part. Okay, now let us dive into the interesting coding part. I'm creating a new project for the linked list. Yeah. It's created. Okay. We are using this linked list using boxmart pointer. For that, I am going to declare a type with a name called pointer. And I am wrapping the box and corresponding node with the option enum. For the node, I am declaring a struct with two fields, namely element of type i32 and next of type pointer. Yeah. Now I am going to declare one more struct, namely linked list, with a single field of name head of type pointer. Now I am going to implement this linked list structure, and in this implementation I am declaring four functions for creating a new linked list, for insertion, deletion, and a print function to print the elements of the linked list. Yeah, function for creating a new linked list is completed. Now let us define the add function for inserting the new nodes to the existing linked list. Insertion function is completed. Now we have to define deletion function. Let us define it. Yes, function for deletion is also completed, and let us write the final function. Yes, definition part is completed, and let us move to have some fun by implementing these definitions in the main. I am going to create an instance of the list. Now let us use the above implementations. Yes, our code is completed, and compiler is also happy and not displaying any errors. Now let us run this project. Now, coming to the advantages of linked list, these are dynamic in size, insertion and deletion can be possible, and the main advantage of the linked list is flexibility. And the disadvantages of using linked list is they do not allow direct access to elements by index. Traversal is required to reach a specific node. Linked lists require additional memory for storing the pointers compared to arrays. Conclusion: linked lists are versatile data structures that provide dynamic memory allocation and efficient insertion and deletion operations. Understanding the basics of linked lists is essential for any programmer or computer science enthusiast. With this knowledge, you can implement linked lists to solve various problems and expand your understanding of data structures and algorithms. Okay, see you in the next video, and if you like this video, please do like, share and subscribe our channel Rust Planet. Until then, keep in touch with Rust and have a good day. Bye bye.